Morning, everyone. Can you hear me? Can you all hear me? Anybody?
Yes, madam.
Okay, thank you.
Yes, doctor.
So, today I actually already uploaded the lecture for correlation coefficient. So I'm just going to play that video now, okay, which is about 25 minutes because I'm not sure all of you have seen or not. So I can answer questions after the video completes. Okay. So meanwhile, maybe if you have any questions, you can, while the video is playing, you can also ask questions in the chat, right? So I will try to answer that. So I will play it first. If you can't hear, please write in the chat box. So that I can double check and see if there are any issues with the audio. Okay, so I'll see you back at the end of the video. Good morning. So today I will be presenting on the topic correlation and regression. So in the previous chapter, we have covered on inferential statistics, right? So inferential statistics, I have showed you how we can do hypotheses. Okay, just double checking. Could you hear the video just now?
Yes, madam.
Can hear, yeah? Okay. Good morning. So today I will be presenting on the topic correlation and regression. So in the previous chapter, we have covered on inferential statistics, right? So inferential statistics, I have showed you how we can do hypotheses to do these inferential statistics, and also use SPSS to do student t-tests to look at the relationship and the differences between two variables. And I also shared for the tutorial how we can create a hypothesis, and then how we can run an experiment in SPSS, okay, doing the t-test, and then using the p-value to either accept or reject the null hypothesis, right? So this is what we saw in the previous chapter. So the following issue we are going to look at is on correlation and regression. Okay, some of you did ask me in the previous class, are we supposed to do only until inferential statistics for our group project? Okay, so if you ask me, okay, but of course you always can refer back to your tutorial lecturer. But if you ask me, the more tools you use, the better, right? That means correlation and regression is another form of statistical test that you can do, and it has different purpose, right? So you can look at the suitability of using this statistic tool and apply it to your project, right? Try to think about where you can use this correlation and regression, right? And then try to show us that you are able to apply it in your data. So I'll move on to the first slide. Okay, so what is correlation? Okay, it is basically looking at what is the relationship between two sets of data or two vectors of scores or two sets of data, right? So the relationship between two variables, it is measured with a correlation coefficient value. There's so many popular correlation coefficient tests, right? For example, you have you have Pearson product movement correlation. You can use Kendall style, and you also have another one called Spearman, right? So the common ones are Pearson, Kendall's, and also Spearman, right? You can even test with both and see, if you use Pearson, how is the data like? How is your score like, right? If you use Kendall's, how is the score looking like? How is the values looking like? Is it similar when you use different sets of tests, right? There might be, sometimes it might be different, sometimes it's not, because Kendall style looks at ranks. For example, Spearman looks at the magnitude of the scores and things like that. So there are certain features that it gives weight to, right? So you can, based on that, you can compare and contrast and see how these two different tools work. So what are the types of correlation? Okay, you have positive correlation, negative correlation, and no correlation, right? So positive correlation basically means high values of X tend to be associated with high values of Y. Okay, that means basically when X increases, Y increases. Negative is just the opposite. When X increases, Y decreases. So there is negative pattern here, right? When there's high value of X, tend to be associated with low value of Y. Okay, no correlation is basically there's no consistency between the two different values of Y and X. So if you can see this graph, most often in non-experimental situation and field settings, in this situation it can tell us about the association. Okay, scatter plots can be seen here, which shows positive and negative relationship. Okay, the example here will be examples of positive and negative relationship of A is the beer sales are positively related to temperature. Okay, so this is because when the temperature increases here, the sales seem to be increasing, right? When you are looking at the negative relationship is as the temperature increases, the amount of as the temperature increases, the amount of coffee sold decreases, right? Basically, when it's becoming more hot, right? People don't drink that much of coffee, right? It's a hot drink, they might not go for coffee. But as the temperature decreases, there are higher sales of coffee, right? Usually in cold weather countries, when it's cold, people tend to drink a lot of coffee, right? Just here is different. When it's getting hotter, maybe it's summer, right? People tend to purchase more drinks in terms, maybe they're having gatherings and things like that. Okay, so I'm just showing here the samples that they are using in terms of negative and positive. All right. Okay, these are some examples of non-linear relationship. Okay, examples of relationship that are not linear are relationship between reaction time and age. Reaction time here basically means like as you age, right? Sometimes when you are responding to something, it might be slower for example, your parents or your great grandparents. For example, when you talk to them, they respond to you slower compared to the young ones, right? Of course, their reaction time and their response time will be slower. So what you can see here is as the age, as the age increased, the reaction time decreased at one point, right? Because you react faster, right? So your reaction time is lesser because you react faster, right? And then as you grow older, the reaction time increases. That means you respond slower. Okay? take time to react. Okay, all right. B, the relationship between the mood and the drug dose. Okay, this can be the dosage of the medication that's been taken, right? So, for example, as the dose increases, the mood for whatever that it is been measured for also increase. So, it's just an example, right? Okay, so types of correlation here, Pearson, as I mentioned just now, Pearson product moment or Pearson Spearman rank, or you also have candle style as well, right? So there are many more, but the common ones are Pearson, Spearman, and Kendall, Kendall. You should try that as well, right? If you use SPSS, it will be there. Even if you use R programming software that you want to use. If you want to check out the others, please go ahead and explore and see what about other correlation. Okay, a Pearson correlation usually signified as rho, right? Pearson is rho. Candles, they call it tau, right? So it's a different name given to the different measure, right? But all these candles, Spearman and Pearson, they are all measured with the value in between of -1 to 1, right? Basically, 1 means positively correlated, -1 means negatively correlated, right? So as you can see, -1 is a perfect negative inverse, right? For example, if a rank there is 1, 2, 3, 4, 5, the negative correlation will be starting from 5, 4, 3, 2, 1, right? That is negatively correlated. It's totally inverse. Okay? If 0 value, it shows no correlation, right? And score of 1 shows perfect positive correlation. That means, for example, just say I have 5 systems, which is ranked number 1, 2, 3, 4, 5 in terms of effectiveness. And then I have another set, same 5 systems using another algorithm, also ranked 1, 2, 3, 4, 5, same rank, same systems. I will get a correlation of 1 if the effectiveness is equally the same. So R2 is called the coefficient of determination of R square, right? Or it's called R square. Can be interpreted as proportion of variance in Y that is contained in X. Okay, this I will explain later on as when you use SPSS, right? Where we actually have generate the score of R square, right? The more a set of data co-vary or appear to be tied, then the stronger the relationship. So basically that's what it does, right? You want to look at how similar are two variables or two sets of data. Okay, usually we do this to see the relationship. Okay, if there's a strong relationship or a strong pattern in between both of them, that means one is very similar to the another one, or they are impacting the other one, right, very closely, then your correlation will be very close to 1.0, right? But if it is going to be totally opposite, that score will be more to -1.0. As you can see here, if there's a high relationship or high connection or high correlation, it will be going towards 1.0, right? If there is no correlation, which is 0 correlation here, this is how the data is. That means when you plot, they are scattered everywhere and you can't see a strong pattern. But if you see the high positive correlation, you can see as X increase, Y increases as well. This is a very strong positive relationship. For negative relationship, it's just opposite. As X increases, the Y decreases, right? A strong, perfect negative pattern is observed here. These ones are in middle. You can see +5 and -5. There is a pattern, but they are still scattered, right? It's not very strong, but there exists some kind of relationship. That's what you can deduce from this pattern. So this is just an example of a printout from SPSS. The value that you get when you run this correlation test. Okay, so this is at the significance level of 0.01. Okay, so if you can see here between cigarette and cigarette here, of course the correlation will be 1 because it's two same data, right? But here, this is where you have to see, okay, is 0.713 is the correlation. That means there is a positive correlation between this variable CHD and this variable CIGARET. What are they actually, right? I think it's not here, but basically I'm just trying to show there are two different variables. So you're looking at two variables, which is CIGRET and CHD. Okay, so this is the value you must see, which is 0.713. Okay, and its asterisk here shows that this correlation is significant at the level of 0.01. Right? Continuing on, correlation does not mean causation, right? What does this mean actually? All right, basically correlation, what you saw just now is whether there is a relationship between two different variables, right? So whether, for example, when the temperature increases, the sales of coffee reduces. When the temperature increases, the sales of ice cream increases as well. Right? So this is something that when you put in the two different data, the correlation basically says that there is a strong relationship, right? But it does not mean that if the temperature increases, ice cream will increase, right? It does not say that it will, right? It doesn't say that this is the cause for an ice cream sales to increase. That is the meaning of causation, right? There is a effect after what happened. For example, just say crime rate in the cities are increasing. Sales of ice cream in the city is increasing. Okay, when you put the two data, most probably they will be highly correlated. Both data are increasing, right? But it does not mean crime rates are increasing because the sales of ice cream is increasing, right? So this is what I'm just trying to tell you, that two variables can be strongly correlated, but it might not be the one. You won't know, or you cannot definitely say that this one variable is the one causing the other variable to change, right? So that is the meaning of causation and correlation. I mean, correlation does not confirm that that is the effect caused by another variable, right? We only can say there is a relationship, but we are not for sure can say that yes, this when one variable increases, the other variable also increases, it is because of that particular variable. We cannot say that. We only can say yes, there is a relationship. That's all, not more than that. So to know further how two variables, to see whether one change in a change in one value affecting a change in another variable, we can do that with regression. Okay, so in regression we are predicting one variable from knowledge of another variable. Okay, for example, personality and job performance, right? How does personality of a person impacts or affects the job performance of the employee? How an attitude impacts subsequent behavior, right? That means how does a person, or in this case the consumer, behaves, right, depending on his attitude, right? So there's so many like this, like you can predict how a knowledge of from one variable, how does it impact another, right? So that is say predicting one variable from knowledge of another. So what is linear regression? Okay, to find the relationship between two variables, right? The regression equation simply is y equals to b plus bx here. I will just put here b0 and b1x describes the relationship between the two variables. Or sometimes maybe you're more used y equals to mx plus c, right? So you might have used that as well, y equals to mx plus c. So it is similar to that, right? It's just I'm using here b0 and b1. Okay? So one variable usually called x is independent variable. The other variable, which is y, is the dependent variable. Because y is dependent, as you can see, this y variable is dependent on these values here. Okay, so the x is independent value, y is the dependent value. Okay, it depends on what are these x values and these values are. Okay, so the two constants here are the bo and b1, which is the m value, right, and the c value. Okay, which if you use y equals to mx plus c, So that will be the m value and the c value, okay, which is called the regression coefficient. Yeah, I will show you further. So this is the simple linear regression. The regression line is the best fit through the data. Okay, this is the best fit is defined as the average line of all the plotted values here. Okay, and it minimizes the distance between the data points and the line. So this is the best fit line between to represent all the data which has been plotted here. Right? So this is called the best fit line. So in regression line, so what you will do for regression in SPSS, basically, you are first asked to decide, identify the best predictors, right? You might have various variables, right, in your data that you have collected for your group project. So how do you want to determine which are the best predictors of a particular variable, right? There will be so many, but which are the best predictors? So that is what you will be going to do in the tutorial for correlation coefficient. Okay. For example, here y equals to bx plus a, or y equals to mx plus c. So y here, the predicted value of y. X is the predictor variable, okay, because this is the predictor variable. Regression coefficient are a and b. So b is what? B is the slope. Okay. Change in predicted y for 1 unit change in x. Right. So there's a change in the slope, okay, in a predicted x 1 unit if we change 1 in y. Okay, so what is the regression coefficient here, which is the a and b? Okay, b is the slope. Okay, so slope here, right, this b value here. Okay, so change in predicted y for 1 unit change in x. Okay, that means every change of 1 unit of x, there's a change of the value of the slope here for y, right? A is the intercept value. Okay, intercept basically means when the x is 0, right? So basically when your x is 0, the intercept value of y. Okay, so that is intercept value A. Okay, sorry, this is basically the same thing, all right? Bx plus A, it's just that here I put B0. So it's basically Bx plus A, right? This is the A value, it's the same. Okay, please don't confuse. I forgot to change this one. Sorry about that. Okay, so this is how in SPSS you will find when you run the correlation coefficient. As you can see, here, this is the intercept value, which is the A value, right? The value A when x is equals to 0, right? So this will be the intercept value. Okay, value of A is this one, it is a constant. Okay, these ones are following your data that you put into SPSS. So this will be all the listed predictors, right? We call it predictors, and this will be the value of B, okay, which is the slope. Okay, so 1 unit change in x produces in this case is 2.095 unit change in y, right? Because this is the slope value, correct? Which is this one. So if one step, that means change of one value here, okay, change of the value of 1 here, you will have the change of the slope value in y. So in this case, 1 unit change in x produces a 2.095 unit change in y. Okay, so and what is this? Okay, this is called standardized regression coefficient. Okay, so if you find a standard deviation value, okay, so one standard deviation change in x will produce this change in your y. Okay, so this value relates to one standard deviation, right? So one standard deviation change in x will produce a 0.419 change in your y value. Okay, so that is standardized regression coefficient. So if you ask me what is the standard deviation, of course that you have to compute from your data, right? That means that amount of standard deviation amount of value change in x will change this amount. Okay.
So R square value is another value generated through the SPSS as well, right? So this R2 value measures the percentage of variation in values of dependent variable that can be explained by the variation in independent variable. So the independent variable here is the X value, right? And the dependent variable is the Y value. So if usually R2 is in between of the range 0 and 1. So for example, if I say the R2 that I get from the SPSS is 0.7654, that means 76.54% of the variance in the dependent value, which is the Y value, can be explained by the changes in the X value. Okay, so we say that the remaining 23.46% is maybe due to random variability, by chance maybe, right? So we will see that in the example, right? In for example, this is the one that we saw earlier actually. So because I was wondering what was the CIGARET, so it's actually cigarettes, right? So cigarettes and CHT, congenital and diaphragmatic hernia, right? That means it's a mortality rate basically. CDH, which I'm not very sure how to pronounce this, but it's about mortality rate, right? So maybe it's something to do with intake of cigarettes and the mortality rate. Okay, so we want to predict level of mortality in a country averaging 10 cigarettes per day. So the average intake of cigarettes here is 10 per day. So the data is based on we have what we predict the rate of CHT be in a country that smoke 10 cigarettes on average. So first we need to establish a prediction of the mortality rate from smoking, right? So you have to come up with that equation. The Y equals mx plus c equation. Okay, so if this is the data you have, 21 countries, you have all these cigarettes taken in average, and then the mortality rate in each of the country. Okay, so with this data put in, right, the two sets of data put in, so this is the coefficient value that you can see here. Okay, so if you can see here, this is the constant value, right? The value of the intercept value, the A value, okay, when your X equals to 0, right? And this is the variable, right? The predictors here is cigarette consumption per adult per day. So when we put in these two data in, so here as you see the question was, what would we predict the rate of mortality rate in a country that smoked 10 cigarettes on average? So what is dependent here? Because you want to predict the rate of mortality, right? So in this case, the CHT is the Y value, okay? And the cigarette smoked is the independent value, right? So here, in the dependent value is the CHT. So the predictor here will be the independent value here, which is the cigarette, and the dependent value is the CHT. Okay, so as you can see, so this is the intercept value, right, when the X equals to 0, and this will be your slope, okay, slope value, and your standardized coefficient value here will be the 0.713. So using these values, like as I told you, this is the A value, this is the B value, the slope, right? So how I make the equation now is Y equals to Bx plus C, right? So Y is the predicted value of Y, mortality, X is the predictor, okay, which is the average of cigarette per adult per country. So Y equals to Bx plus A here. So I replace the B value, which is the slope value. If you see, this is the slope value, 2.042. And then X plus C, this is the A value from here, 2.367, the intercept value. Okay, so I replace them here, and then the question says if the average cigarette smoked is 10, right? So X here, cigarette is 10, right? So I replace that here, I'll get Y equals to 22.787. So my conclusion here will be, we predict 22.79 people out of the 10,000 in a country with an average of 10 cigarette per adult right, will die of CHD, right? So if you ask me where this 10,000 come from, actually the data has that value, okay? So that's why when we generated this, there is written here, right? The mortality rate per 10,000, okay? So that is where I took it from, right? We predict 22.79 people of the 10,000 in a country with an average of 10. Actually, this is CAC, right? Child, cigarette, the adult, and the CHD will be a country, will die of CHD. Okay, I will give some links, right, which will be in the slides, as well as I'll try to get some other examples, and I will put it in the spectrum, right? You can try to have a look on the various ways, okay, of trying out this regression equation. Actually, I will be explaining after this in the tutorial how you can, we will do step by step, okay, how we can formulate, okay, this equation, and we also will go through the step by step ways of identifying. For example, if there are 10 predictors, how do we know which predictor should we include in this equation, right? So usually the significant ones are the one we will choose to put in this predictor, because not all predictors are good in are good to predict value of another variable, right? So that is why we have to choose which is the best predictor. So for that, we will also will be doing some of the tutorials, which you will see next in the next recording that I will do. Okay, all right. So thank you very much. If any questions, we can always discuss in our live lecture.
Okay. So managed to listen?
Yes.
Okay.
Yes.
Because I know some of you, when I upload, right, just maybe sometimes you might not get the chance to see the video. So that's why I decided, why don't I play the video, right? So now I can open for questions, right? So that questions can be, okay, I see one question here. Do we need to know the formula to calculate Pearson rho? No, you don't, right? You can if you want to, because later on when you want to do more in detail research or anything, then yes, you need to know how the formula works, right? But for this class, it's good enough that you know how to apply, right? So it's good enough that you know how to apply the Pearson rho, and how to apply the others. You know, if you have tried using SPSS or R, you can already choose, right, whether you want to use Pearson or Spearman or candles. But it's good to know what is the difference between, for example, candles and Pearson, right? Why are there so many correlation coefficient tests, right? So for example, if you want to try with Pearson, and then you want to report the results, and then later you want to try candles, then maybe you want to explain why are they different, or what one tool assess that the other tool doesn't, right? So if you like, you can explore that and you report it in your group project report, right? But for now, if you just use one, that's good enough, right? Pearson or candles or Spearman, right? I would suggest you use Pearson or candles. Anything else? You can even ask anything related to group project as well if you like. Anything else? So meanwhile, let me see. Maybe I wanted to show this. Hold on, yeah. So you know what is R2? R square? Are you all clear of what is R square?
No.
No. Okay. Can you see my screen?
Yes.
Okay. So I just added some. This is not in the slides that we uploaded, but I just added some just to show to you. Okay, R square is basically is this. Okay, if I can picture out, these are two different graphs. Okay, I did not put the y-axis and x-axis because I just want to show you the concept of R square. So in regression, usually you do a best fit line, right, to represent in average how the plot or how the data is distributed. So the first one, for example, just say there are 9 values here. Okay, 9 observed data here. So if there's 3 data out of the 9 falls on the best fit line, okay, so we say that the R square is 33.33%, right? So usually the value is between 0 and 1. So in this case, the R square value will be 0.33, right? So where 0.33 is actually you deduce as 33% of the data actually fall on the best fit line, right? So you know that the rest of the data, for example, the 67 points may not fall exactly on the best fit line, but it may be around it. So the higher the R square value, the more data actually falls on the best fit line. For example, here 6 out of 9, excuse me, 6 out of 9 data actually fall on the best fit line. So most probably, okay, my prediction, your R square will be something like this, 67%. Okay, so that is actually the meaning. So the higher your R square, that means it is more closer or falls exactly on the best fit line. Okay, basically that's what it means. So when you plot this graph, this is how you can deduce. So of course, the higher the R square value, the better it is. That means it is more closer to the best fit line, right? To represent your relationship between the two variables. I actually uploaded an explanation on this in Spectrum yesterday. Okay, if you are in my tutorial group, I would have shared the video in the Telegram link. But if you are not, I would have uploaded in the Spectrum, okay, where you can find the lecture, recorded lecture and all. I would have uploaded a YouTube file to some explanation on this as well.
Sorry, Doctor.
Yes.
Just now, Doctor, you say upload to Telegram link. Do we have Telegram link? Because
No,
I don't know.
as I told you for my group, because every lecturer, they have their own way of communicating with students, right? So some of them use WhatsApp, some of you use Telegram, some use direct in Spectrum itself, right? So there's various ways. Yeah, so for my tutorial group, I have a Telegram group, right? For
Okay,
group 6 and
understand.
7, yeah. But don't worry, whatever that I have uploaded or shared with my students, I also, of course, I will upload in Spectrum, right? So I already also put the link in the Spectrum to that YouTube files. Okay, so I do share in Spectrum, so that's why you always have to check the Spectrum as well. Because if I find some videos are very relevant to your group project or to your lecture, I will upload in our Spectrum for our group, right? Which is tutorial 1, 2, 6, and 7, if I'm not mistaken. Okay, anything else? So this week is going to be a Christmas week, right?
Yep.
Yeah, I understand that. Let me see. There's a question. Oh, that's a long one. Doctor, I want to ask a question regarding our group project. So far, our group has collected data with a column of string data that are comma separated. For example, data in a single column, apple, orange, grape. However, I face trouble to transform the data that is in single column that, oh, okay. Okay, may I know you are from which group? Because any specific related to SPSS, I would like to do it one-to-one. May I know you are from which group? Hausen? Tutorial 2, Dr. Ho's group. Okay. Because I could, let's see. The doctor experienced this with the use of spaces which I really can't find from social on. Okay, Hausen, can you email me on this? Okay, I will try to contact you directly. All right. Anything related to execution in SPSS? Okay, kindly can you email to me as well? You can send it here because since you're not in my group, okay, you just email it to me. Maybe I can try to attend to you on your issue with SPSS. Okay, because sometimes I need to understand actually what issues you're facing, right? Okay. Anything on group project. So, okay, those who are here, what I understand from Dr. Ho is, he said that you are also allowed for Dr. Ho's group, right? Tutorial under Dr. Ho, they mentioned that you will be, you are allowed to present much earlier, right? For your group project, okay? So the same thing applies to my group as well, group 6 and 7. If you have completed much earlier, you can present your group project much earlier. So you just have to contact your lecturer for your tutorial group. Okay, so for Dr. Ho's group and to my group, okay, Dr. Sri's group, you can contact us to inform if you want to present much earlier than week 14. Okay, because some of you I know might have done it, completed it. You want to present much earlier. So what I understand, Dr. Ho as well, because I'm also doing the same way, which is you pre-record, right? You pre-record your presentation with your group. And then we are only going to do live session for Q&A. Okay, so for that, Dr. Ho and I will be preparing a schedule, right? When your groups will present. So anyway, the group 1 and 2, please make sure to ask Dr. Ho on your presentation. Okay, I'm sure you have some arrangement. So I'll be doing the same arrangement with my group as well. We will have a schedule for Q&A session. Okay, but your presentation you can pre-record and share it with the lecturer of your tutorial groups. Okay, so that's what I believe the arrangement for Dr. Ho as well. Okay, you can double check with him, but that's what I understand, that you are pre-recording your presentation. Q&A only we are going to do online. Okay, because we want to avoid any network issues and all, so we just want to keep it minimal online face to face. So we might just do a schedule for your presentation for Q&A. So how's your group project all going so far? Yeah, anyone want to ask anything?
Hello, madam.
Yes, you are.
Madam, for the pre-record, do we need to show our face or is it okay if we just show our content?
It's better to have your face, all right?
Okay.
Yes, we want to see you present.
Okay, thank you, madam.
Welcome.
Doctor, I have a question.
Yes.
To verify the hypothesis, we have to screenshot the test, right?
To again, Daniel.
To verify the hypothesis that we drafted before this, we have to screenshot the test that we carry out in SPSS, right?
Not really, because if you start putting all the screenshots from your SPSS, you won't have space for your report, right? So that is why we suggest that a good way of reporting is you try to use tables, right? Create your own tables and put in the data, the values that you got, for example, the p-value, or the values alone, extract it from SPSS and put it in your own table that you have created. Because if you start copy paste all the screenshots from SPSS, there won't be any space in your report. So we don't really want to see. We trust the students, right? We believe the students. So you don't have to screenshot everything, right? Because at the end of the day, we do have a Q&A session where you have to explain it. So it's fine. You just put it in the table form in your report. You don't really need to put screenshots.
All right, got it. Thank you so much, Doctor.
All right. Because if anything at all we want to verify, we will do it during Q&A, don't worry. Okay, so be prepared with whatever SPSS results, or all that screenshots. If you want, you can keep it in a different file which you can use during your Q&A. Okay. Anything else? So try to do regression as well, okay, for your group project, because last session, usually the final ones, not many will try to do, you know, they will do t-test, ANOVA, they'll try the Tukey. Sometimes, okay, they might, not many tried regression, right? Maybe they do face some issues. For example, their variables that they have chosen for their study might not be suitable for a regression, right? But just give it a try and see, all right? See if you can come up with a regression equation and how you can predict one variable from one with using another, right? It'll be interesting to see that if you have tried up to regression. Okay, maybe I could share one more is, I had a question yesterday. They asked, should we use both parametric and non-parametric? Okay, I do predict that your data might follow a non-parametric nature because your size or your sample size might be quite small, right? I mean, you don't have thousands and thousands of data, right? So possibly when you test for normality, your data might be not normal. So when your data is not normal, you cannot use parametric tests, okay? But I do not restrict, but you should know that if the data is not normal, you are not advised to use parametric. You're supposed to use non-parametric. So please understand that when to use parametric and when to not use parametric. Okay, but I do allow you to use parametric. Okay, also, or during your presentation, you also can say that your data, you know, the nature of the data was non-parametric. Okay, but for exploration purpose, you also tried it with parametrics. Okay, so make sure you know when to use parametric and non-parametric. That is important, right? That means whether you choose parametric or non-parametric statistical test, it totally depends on whether your data is normal, data is independent, right? So if it fulfills all these criteria, you can use parametric. If not, you're supposed to use non-parametric. Okay, so in this case, what you can do is, if you use non-parametric, since it's not normal, you can say for exploration purpose, you also tried it with parametrics. You can do that way. Okay, so don't like at the end, you know, when you come for the presentation, you say you use parametric, but ask you why you chose parametric, you don't know. You should know, right? What is the difference between parametric and non-parametric? There are different sets of tests for parametric and non-parametric. Okay, which everything you can do in SPSS as well. All right. So there's actually one more lecture which is on non-parametrics, which will be delivered by Dr. Hu. But he said that he will confirm whether there is a class next week or not. Okay, because I already supposed to do this class next week, but I did before. 1 week before already, I completed these two, regression and also the t-test. One of the reason is because I want you to use this in your group project. Okay, so the earlier you understand it, the better, so that you can apply it. So I didn't want to wait until the end of the semester. Okay, so he asked you to check in Spectrum whether there's a class or not next week. Okay, if there's no class next week, then it'll be the following week. Okay, so always please check Spectrum and Microsoft Teams, right? He will put in the schedule meeting if there is one next week. This Wednesday, I will have tutorial online, but I'm not going to do online SPSS, okay, because it really slows down my PC. Sometimes, even last class, I had an issue, right? So what I did, how many of you already seen my tutorial? I already uploaded yesterday. Anyone?
Not yet, Doctor.
Not yet. Okay, I already done the tutorial 9, the tutorial 9 recording. Went through all the questions inside the. You can watch, right? There's 5 questions in tutorial 5. If you look at that, you try that, you will understand the chapter that we learned today. Okay, it will be much clearer. So I already preloaded. So please go through that. I really appreciate if you can come to class on Wednesday after trying that, right? I mean, after going through the tutorial, right? Don't wait for Wednesday to try your tutorial. You can you try much earlier. So if you have any questions, we can discuss, right? And also the Wednesday, again, I'm going to use it as a help desk session. So if you have any questions on group project, you can always bring it on the class day so that you can even share it in the screen here if you want to ask anything. right? Okay, any other questions? All of you are fine, okay? Can do the group project?
Yeah, hopefully.
Right. Okay, anyway, I'm done with the class, but if you all want to stay on to ask any questions, you can please continue staying. Maybe I'll stay up till 10 o'clock, right? So anything you can ask in the chat box as well. Okay, so we can end the class here, all right? Thank you.
Thank you, Doctor.
Thank you. All right.
Thank you, Doctor.
All right. I will
Thank you,
just stay
doctor.
here until 10. You can ask me any questions if you have.
I have a questions to ask.
Yes.
I would like to ask, if we finish all the t-tests and ANOVA for the 6 hypotheses that we are proposed, and then we have concluded that means that we already have the basic marks for the assignment, right?
What do you mean by basic marks? Yeah, the full mark, is it?
Yeah, that means we fulfill the basic requirement. If we want to do like extra things like regression, correlations, and also correlation, and also the non-parametric tests, that means it's the extra features for our assignment, right?
Actually, I wouldn't say that, Hausen, because if you see, regression is part of your lecture, right? It's part of your lecture. Actually, it's not something different. That is why I would suggest all of you to try even regression, correlation. Didn't you do correlation?
We need to see the variable whether it's suitable or not.
No, correlation is quite easy actually. Usually that is doable, right? Correlation is not something that you just need to take 2 variables to see whether there is a relationship between them. Right? Correlation is quite easy. You should do, right? Everyone should do correlation. But regression, it depends a little bit on the data, right? That means, do you have that means because correlation, just you need to say whether there is a relationship only, right? It does not look at whether one is a predictor or not, whether the data is suitable or not. Regression is the one you have to see whether is one step further after correlation is regression, right? You want to see specific predictors for a particular variable, right? So that maybe you can ask Dr. Ho if you are from Dr. Ho's class. Are you from my class?
No.
Dr. Ho. Okay, then you please check with Dr. Ho as well on what the question that you asked, because for my class, I would want them to do until whatever that we have learned. All right. So of course, when you see, you try to do even regression, you don't have exact, specific data. You can create something from regression, but you just give it a try and see. All right. So I wouldn't say that if you do until t-test, you'll get full mark. No. Right. Because correlation is something that you should do. Right. Possibly correlation or regression. Of course, if you ask me, regression should be there. In fact, even non-parametric, you should give it a try, because it doesn't really take long to do a non-parametric test. The same data that you use to do t-test, maybe you can use Mann-Whitney to do something for ANOVA and using Mann-Whitney, right? So you can just call the function and then you can just report it, right? So please try everything. That would be my advice, right? Don't stop at t-test, because t-test is very minimal. Okay, correlation has to be there.
So can we exceed more than 6 hypotheses?
Did Dr. Who say maximum 6?
Maybe can exceed. I need to clarify with him.
Yeah, can exceed, but I remember someone asked, and in the group, in the teams, I think, and Dr. Who did reply that it doesn't mean that if you do extra hypotheses, means you get extra marks. He did say that, I remember. So actually, in my case also, I do not go by the number of hypotheses. Okay, what I look at is the different types of tests they do. Okay, the more types of statistical tests they do, the better it is. Okay, because a student can do 10 hypotheses, but all the 10 use student t-test, compared to a student who would have done for example, 6 hypotheses, but all the 6 are different tests. So which would you, if you ask me which is better, of course I would say lesser hypothesis, but they have tried various statistical tests. That would be better than you have more hypotheses, but you tried only 2 types of statistical tests.
All right, doctor, thank you. Okay. I think most our problem is to transform the data to string value to numeric value only. Yeah. String means, okay, now it's all in text, is it? Yeah, because Google Form will return us the strings type of the respondent respond to us. So it's like a value and then comma, value, comma, like that? Is it? Yeah, because it's multiple questions. So they choose multiple choice answer. Then the Google Form will record it as string separated by the comma in a single column. Or maybe you can email me and see, let me have a look. All right, see how I would like to see how the data looks like. And then your issue is to put it in the SPSS, correct? Yes. Okay, let me have a look. Even if you try to import it in Excel and then put it in SPSS, is it a similar problem? You cannot put the data into different. Anyway, I think I better look at your data first so that I can get a better idea, right? Right, thank you, doctor. Okay. Anything else? Okay, if nothing, you may leave, all right? Make sure, don't forget to give your attendance. Sorry about just now. We forgot to put the attendance link actually. So now it's there, so please give your attendance. Okay, so I will just stay here another 4 or 5 minutes, okay? Okay, I think there's no more questions. Last call, any more questions? Anyone want to ask anything? You can chat as well if you have any.